Lesson 2 of our fractions unit is about multiples. And we'll start with a definition. A multiple of a number is any product of that number and an integer. If you're wondering what an integer is, you can just think of, for now, like the whole numbers that we know. We're going to expand on that in a couple of units, okay? So, for example, 20 is a multiple of 10 because 2, one of these integers, times 10 is equal to 20, okay? We wouldn't use the word factor there. We couldn't say that 20 is a factor of 10, right? So, multiples are bigger versus factors are usually smaller than whatever number you're talking about. All right, let's list the first 4 multiples of whatever number they give us. So multiples of 3. This is actually just skip counting. So if you wanted to put a little note here, a multiple is just when you skip count. So 3, 6, 9, 12. Do the same thing for 12. Start with 12. Then it would be 24, 36, 48. And if you have a hard time with these, you can always pull up a multiplication chart. Multiples of 5. 5, 10, 15, 20. And then multiples of 7. 7, 14, 28, 35. Okay? All right, so the next thing is basically what's the purpose of knowing what a multiple is. One thing we use this for in 6th grade is called least common multiple, okay? And we're going to shorten it to LCM, okay? So the LCM is the smallest positive multiple of 2 or more numbers. So sometimes it's 2 numbers. Sometimes you're going to look for the LCM for maybe 3 or 4 numbers even. Okay? All right. Let's find the LCM. Let's practice. So to find the LCM, we have to start by finding multiples. So I'm just going to set it up, 4 and 6. And now I'm going to skip count. So 4, 8, 12, 16. Let's see if that's enough. 6, 12, 18, 24. And actually, I see one that matches. They both have 12. So that means that the LCM is 12. The smallest number that both of them have as a multiple. Or the smallest number that shows up when you skip count. All right, let's try the next one. 8 and 12. Count by 8s. 8, 16, 24. That sounds familiar. I think that's going to be enough. 32. Now let's try our 12s. 12, 24, 36. So we didn't even need that many because now we have the 24s that match. So that means the LCM is 24. And again, if you need a multiplication chart for this, that's absolutely fine. All right, now here we've got 3 numbers. If we want to find the LCM, we have to find the smallest number that all 3 of these share. Chances are it's going to be a little bit higher because we have 3 numbers instead of just 2. So 5, 10, 15, 20, 25, 30, 35. All right, let's see if that's enough. 6, 12, 18, 24, 30, 36. Hopefully we can get a 30 out of this 15. So it'll be 15. Double 15 is 30. And then you get 45. So we definitely see all 3 of them have 30. So the LCM, least common multiple, is 30. The smallest number that all of them share when you skip count. Okay, let's try a word problem. We're going to find the LCM. 2 lights are turned on at the same time. One of them blinks every 8 seconds and the other one every 10 seconds. After how many seconds will they blink together again. Remember, we're squiggly underlining the question, and then I'm circling numbers and underlining keywords. So one light is 8 seconds. The other light is 10 seconds. And we know we're finding the LCM. So that's what I'm going to put in the what I need to know box. A couple of ways to know that is when you kind of have this language like the same time and after how much time will they blink together again. It's kind of a hint that it's LCM. Sometimes they'll be a little bit more obvious about it too. So we'll go ahead, we'll do 8 and 10. So 8, 16, 24, 32. If you're thinking about tens, you know you need it to end in a 0. 40, 48. So I think that 40 is going to do it because we'll go 10, 20, 30, 40, 50. So that's the smallest number right there is the 40. Now when we answer this, yes, the LCM is 40. But the question's asking after how many seconds will they blink together again. So I'm just going to write 40 seconds. I'm not going to say LCM. All right. Now, another reason why this is actually super useful is with equivalent fractions, okay? And we're going to throw out kind of a big word here, and we'll see if you remember it later on, okay? So to find equivalent fractions, you want to multiply by any fraction that is equal to 1. What do I mean by that? So, for example, like 5 over 5 is equal to 1, or 9 over 9. So a number over itself. And the number 1, when you're in multiplication, has a really fancy name. It's called the multiplicative identity. So multiplicative comes from the word multiply, okay? And identity is like who you are or staying the same. So this word basically means the number that makes things stay the same, which when you're multiplying is 1. Because if you multiply by 1, nothing happens. So it's just a fancy word there. See if you remember it when we come to the next class, okay? All right, let's try it. To create equivalent fractions using multiples, all we have to do is multiply by some fraction that's equal to 1. If it's not equal to 1, then we're kind of changing the value and we're making a big mess of things. So we have to make sure it's equal to 1. So I'm just going to choose a random number. How about 4? If I just multiply by 4, that's not going to work. What if I do by 4 over 4? This is equal to 1, so it's okay. 1 times 4 is 4. 6 times 4 is 24. Okay? All right, how about, let's use 2 times 2 times 2. 3 times 2 is 6. 8 times 2 is 16. So we've anti-simplified or done the opposite of simplifying. We're making bigger fractions. When I say that, I mean the numerator and denominator are not simplified anymore. Okay, how about 5 times 5 times 5? As long as you use the same number, it's okay. 20 over 45. Okay, now this last one is actually a mixed number, and we're going to need to change it. So if you remember, you take these two and you multiply them. So 5 times 2 is 10, and then you add that to the top. So 10 plus 2, which is going to be 12 over 5. Technically, that's an equivalent fraction, but let's change it up, okay? Let's try multiplying by 10. So we can do times 10 times 10. So remember, times 10 just adds a 0. So the 12 becomes 120 and the 5 becomes 50. And there you have it. Okay? And now we have a reflection question here that I'm going to have you answer in the Ed puzzle. When is it helpful to make an equivalent fraction? So when have you ever needed to change what a fraction looks like? Maybe so that you can do something with the fraction. All right?